Chapter 6, Segment 3. The depth that you see depends on whether you converge or diverge your eyes. Divergence requires focusing on a point beyond the plane. Because the images falling on the two retinas in the divergence method are reversed compared with the convergence situation, the disparities are reversed and the perceived depth will be reversed. Stereo blindness is the inability to make use of binocular disparity as a depth cue. This term is typically used to describe individuals with vision in both eyes. Someone who has lost one or both eyes is not typically described as stereoblind. 3 to 5% of the population lacks stereoscopic depth perception. It was generally supposed that stereopsis occurred relatively late in the processing of visual stimuli. Bella Jules spent most of his career at Bell Labs and thought that conventional wisdom might be backwards. Also, he theorized that stereopsis might be used to discover objects and surfaces in the world. Random dot stereograms is a stereogram made of large number of randomly placed dots. Random dot stereograms contain no monocular cues to depth. Stimuli visible stereoscopically in random dot stereograms are cyclopean stimuli. The important point about random dot stereograms is that we cannot see the squares in either one of the component images. Cyclopean, referring to stimuli that are defined by binocular disparity alone, named after the one-eye Cyclops of Homer's Odyssey. Stereo, movies, TV, and video games. In our day, 3D movies, TV, and video games are the new stereoscope. 3D glasses separate the images of the two eyes so that disparity provides additional cues to depth. Some of the earliest 3D movies were reviewed with anaglyphic glasses, with red lens for one eye and blue or green filter for the other eye. Later, filmmakers used polarization to separate the images to the two eyes, and polarizing glasses were used to view the films. Many modern 3D movies, TV, and video games use special glasses that contain liquid crystal display technology and enable the presentation of images to each eye that are synchronized with the images on the movie, TV, or computer screen. In a method known as lenticular printing, the images are digitally split and interleaved at a fixed spacing. A special array of many tiny lenses placed on the screen ensures that the left eye sees only the left image and the right eye only sees the right image. This setup permits three-dimensional viewing without glasses. Using binocular stereopsis. It can provide useful information about metric depth only for distances up to 40 meters. We can also use stereopsis to have a better look inside the body. Stereoscopic displays are beginning to be used in radiology, and they can reduce the error in important tasks. In people with normal binocular vision, visually guided hand movements are significantly impaired when viewing is restricted to one eye, owing to the fact that binocular depth thresholds are about a factor of 10 better than monocular thresholds. Loss of stereopsis may also result in unstable gait, especially reduced accuracy when a change of terrain occurs, and difficulties for children in playing some sports. Correspondence problem. In binocular vision is the problem of figuring out which bit of the image in the left eye should be matched with which bit in the right eye. The problem is practically vexing when the images consist of thousands of similar features, like dots in the random dot stereograms. The problem is simpler if we look at a blurred version of stereogram. Blurring leaves only the low spatial frequency information. Uniqueness constraint. In stereopsis, the observation that a feature in the world is represented exactly once in each retinal image. The constraint simplifies the correspondence problem. Continuity constraint is the observation that except that the edges of the object's neighboring points in the world lie at similar distances from the viewer. This is one of the several constraints that have been proposed as helpful in solving correspondence problems. Perception. The most fundamental requirement is that input from the two eyes must converge onto the same cell. This convergence does not happen until the primary visual cortex. A binocular neuron has two receptive fields, which are very similar, shaping nearly identical orientation and spatial frequency tuning. Many neurons respond best when the retinal images are on corresponding point in the two retinas, thereby providing a neural basis of the horopter. Many other binocular neurons respond best when similar images occupy slightly different positions on the retina of the two eyes. Gian Poggio and his colleagues found disparity-tuned neurons of this sort in V2 and some higher cortical areas. Some neurons responded positively to disparities near zero, that is, to images falling on corresponding retinal points. Other neurons were broadly tuned to a range of cross or uncrossed disparities. Combining depth cues, the visual system generally arrives at a coherent and more or less accurate representation of a three-dimensional space. The Bayesian approach, a way of formalizing the idea that our perception is a combination of the current stimulus and our knowledge about the condition of the world, what is and what is not likely to occur.